Alright guys, we're going to take another peek at this guy right here. This is that Breakout board, which if you remember, I had, I don't know if you do remember, I had 21 red dotted bad chips on this board. There's, count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And there might be more because some of these don't have markings on them, so I can't test them. Like these, I don't know what they are. I have to look at the schematic and find out what these chips are before I can really test them to find out if they're good or not. So there might be more than 21. But and another thing that I did to this board, if you're noticing, it looked better. Does it look better? I bathed this thing 3 treatments in toilet bowl cleaner. It was so corroded and just had that nasty film of nastiness on this board. I did 3 treatments with toilet bowl cleaner to wash away that corrosion off this board. I got a lot of it off and it looks way better. The board looks so much better. You can actually see the traces, you know. But anyway, I had contacted the owner of this and I gave him the bad news about how bad this board is, and it's, you know, unfortunately I would not be able to do it for my standard fee that I charged quoted for this because of, you know, and I left it up to him if he wanted me to move ahead with it, and he didn't. You know, at first he said, no, you know, let's just put it aside and not worry about it. And I was like, okay, you know. Well, he got with me later on in the day, today, and said, hey, let's move ahead with this board. And you know what, I'm excited because I really want to bring this board back to life. You know, it's in good shape now. It's decent. The back of it is in really nice shape. The back of it is really clean. You know, it's got a couple marks right here. That's just like funkiness from soldering. Someone soldered caps, you know, replace these caps. That'll just brush right off. But it's not in bad shape. And I just got done fixing Time Pilot. Time Pilot's doing a burn-in. And I'm already chomping at the bit to get to this guy. But I'm going to let Time Pilot run for at least 3 hours before I dive back into this guy. But yeah, we agreed on an adjusted fee. And we're moving forward, and I couldn't be happier. So, sweet. We will be back. Alright guys, I've been working on this Breakout board here. I removed all of the chips that I had tested and deemed to be no good. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 chips. Removed. And I got my list here of what is what. I went through and the positions and the type of chip it is, and I wrote them all down, and I was like, I'm just going to remove them all one shot. And you know what? For as old as this board is, and as crusty and corroded as this side was, these desoldered so easy. It was absolutely no problem. It was quick. Yeah. Okay, well, I guess next thing to do is repopulate. So I'll get to that tomorrow. I'm done for the night. I've done enough. So we'll be back tomorrow. And just for giggles, guys, I'm going through with my chip tester with all these bad chips. I've already done 3 of them and they're not found. I'm just popping them in here and pushing the button. And if they're found, it'll come up. Not found. Dead. Not found. Dead. That one's got a broken leg. Or this one right here was the one that had the wire soldered to it. It's got a leg broke off. So this is an 86. Not found. Dead. This is an 02. Not found. Dead. This is another 86. Get down in there. I gotta straighten a leg or something. Okay. Ooh, LS86. That one was actually good. I know some of these I marked them bad, even if they looked a little suspect. I marked them bad. Not found. That's a 161. This is a 04. Ooh, it's good. This is, I don't even know what this is. I can't read it. Not found. Some of them, like, they were actually doing something, but the signals just didn't look good. I am not going to reuse these ones that said it looked good. This is an 86. Not found. 02. Not found. 74. A lot of dead flip-flops on this board. Dead. And this is another 04. Not found. Dead. This is a 00. Not found. Dead. This is a 161. Count. Dead. 00. Dead. Another 161. Dead. It's amazing this game actually did anything on the screen. This is a 74, a 08, and gate. And it is dead. This is another counter, another 161. And you're dead. And here we have a 74, another flip-flop. Dead. Here we have another Another counter, another 90. There are 93 16s in this board. That is actually just a 161. Same thing. But they're marked 9316. And it's dead. And here we have another 74. Dead. So two of these guys actually tested good. But like I said, I know that there were probably these two chips right here that actually half-ass worked, and it'll probably pass in this. Like one of the 86s, I'm telling you, I know right now this has got to be the one. One of the outputs was half-ass floating. But it was a square wave, but it was a float. It was offset up. It was offset high. So that's probably that flip-flop, or that 86. But yeah, 23 technically bad chips, but really 25 bad chips. Isn't that crazy? 25 of them, guys. All right. So we will we'll get to populating that tomorrow and see what happens. Now there are some other types of chips on here. There's a there's like a row of 8-line to 1 mucks. There's like 6 of them in a row. I probed the outputs, and the outputs, there's complementary outputs. It's the same thing as a 151 functionality wise, but it's a different pinout. But luckily, I probed only the outputs. The two complementary outputs I probed, and they looked good. The outputs looked okay. That does not mean that it's okay, but at least they looked good. But if one of those are dead, and I couldn't find any of those online, it's like a 9312 is the number. It's actually the same thing. It's an 8-line to 1 decoder. Same functionality exactly as a 74LS 151, but it's just a different pinout. So if one of those or one or more are bad, I'm going to have to use a 151 and just rig it somehow, you know. Yeah, that'll be interesting. But hopefully they're all good. They looked good. But yeah, so we'll see. But we should get a lot better results replacing all of that junk. So, all right, we'll see you tomorrow. We'll be back, and tomorrow will be exciting because we're going to repopulate this thing and see what it does. See you then. Yeah, before I do call it a night, I wanted to go and just kind of say that the way that I'm doing this is I went through simple gate stuff, easy stuff, and eliminate, flip-flops, gates, that kind of thing. Found all that bad junk. A lot of this stuff well, basically, like some of this stuff, like some of these counters down here didn't have outputs, but I couldn't tell if they were good or not. There's more counters and stuff down here and on the board in other places that I just couldn't really tell if they were good or bad because situation did not dictate that they would have an output. Like a lot of them were just high or low on the outputs. So what I needed to do is get all of this junk replaced so that I get good signals going on this board. Then I can further troubleshoot once I've got good signals going to these chips. And then I'll be able to probe these and see, okay. And another thing that's weird that I don't like about this that I'm going to modify is the clear pins on the 161s. They did not pull high. They left them floating. So every one of those 161s that they did not pull high, I'm going to pull high with a 1K resistor. Every one of them. I'll solder a 1K resistor right over top of the chip over to power. Pin 1 to power. Because I don't like that, leaving it floating like that. No, no, no. Let's pull it high so that it don't clear ever. If it's not supposed to clear, let's make sure it don't clear. You know, shouldn't leave them floating. That was, I don't know why they did that. But, yeah, it's weird. So we'll go through and mod that, make that change, and yeah, so, alright guys, have a good night. See you tomorrow. Alright guys, this thing has been repopulated. There. All over the place. All those 25 chips. So now I'm ready to fire this thing up and we'll see what we get. I imagine that there will probably be some issues still, but we'll really be able to pinpoint those issues now that we've got good logic on the board. So let's go ahead and fire it up. And it is on. And it is definitely doing something different. I think we need to, let me mess with the, let me come back. I'm going to mess with the vertical hold really quick. Okay, we're getting somewhere. But you know what? I don't remember wiring audio. I got to check that. But it's still looking a little weird. I think we got, I don't know, some kind of issue here, but it's not bad. We're a lot further. Let's put it that way. But it looks like we still got some work to do. But we're getting there. So I'm going to do a little research on whether I wired up audio or not. I think I did. How the audio works, I don't see an amplifier on here. I wonder if this was one of those things where it's externally amplified. It probably is. So, okay. Alright, I'll be back, guys. Okay, as you can see, we've got some issues to work on. This is our paddle is good over here, and then it freaks out over here. So, and I had to actually wire in a serve button, and you'll see we got issues with this too. It'll serve, and boy does it break out. It just breaks right through there. There's no stopping that ball. Yeah, so we got some problems, but the game is actually playing, which is incredible. It is actually playing. There's no sound. I'm going to have to order sound amp is LM380. Nope, the sound amp is fine. So we're just not, we don't have sound. We have sound failure someplace. So that should be easy to find. But the amp seems to be fine. So, well, we got to figure this paddle out. It's crazy over here, but it's good over here. But over here, just I'm going crazy. I can't help it. I'm going crazy. And then the ball, you serve, and the thing just goes right through there. Boom. Breakout. Breakout. Alright, well, I'm going to do a little probing around. I'm going to look at the schematic. What do we want to do first? I don't even know. Let's try to fix the paddle first. let's concentrate on the paddle circuitry. And I might have to buy some parts for this because I was looking at the schematic a little bit, and there is an integrated circuit which is an SR latch in a package. It's an LS, or it's actually a 74279, and there's a slew of those things used on this board, and I don't have any of those. I've never encountered a system that uses that chip. So it must be really old school. So I might have to buy some of those. I think they're used in that circuit. But yeah, I'm gonna poke around the paddle circuitry and see if I can't figure that out. Okay, this timer is in the paddle circuitry. And I'm looking at this capacitor across pin 5 that I believe is a $100. It's across pin 5, and then you have a 0.01 right here, which I believe is across pin 5 as well. And it looks like we have a purple, black, I don't know what that is, yellow, purple. We have a resistor going from a 74, that's a 74, no, that's a 4066. 4066 has a resistor starting with 4 going to pin 6. Let's go look at the schematic. Man, we come over here and we get to our schematic. So we had a resistor from an 04 going to pin 5 or something, 6 or something like that. I don't remember. I already don't remember. But we have a 0.01. There's our 0.01 going from ground to pin 5. And we also have a 1 microfarad capacitor, which is this guy, which is going from ground to pin 5. It's in the wrong spot. That's supposed to be going to pin 7 and 6. So I'm going to take that 1 microfarad capacitor right there, and I am going to move that positive lead to pin 6. And I bet you the paddle works properly. Okie dokie. Well, the paddle has completely disappeared. Completely disappeared. But one thing that I had noticed, anyway though, if I'm not going to be able to do this, but now that I have this in the right spot, and you look at, you know what, I don't have, I got to set this way slow. Anyway, what I was getting at is this LS30 right here is like a 10 input or something, like 8 input AND gate or NAND gate. Anyway, this is the output. The output is floating. So I'm going to replace this chip right here, and that I'll show you what that does. That's an LS30. It is right there. Paddle enable. It gets all of these. It looks like 1, 2, and 3 are pulled high. No. Nope, it looks like 2 is pulled high and maybe 3. It's hard to tell. 5, 6, 11, and 4, and 1 are all going to be, regular good old signals. So it looks like 2 and 3 may be pulled high. 5, 6, 11, 4, 1. Let's go look at this thing. But the output on pin 8 right there is the one that you see is just completely floating out there. So maybe fixing that capacitor on that 555 just made the, exposed this. I don't know. But anyway, let's go take a look at all these inputs. Let's look at 5, 6, 4, 5, 6, 11, 12, 1. 4, 5, 6, 11, 12, and 1. 4, 5, 6, 11, 12, and 1. Let's see what they look like. 4, 5, 6, 11, 12, and 1. Here's 1. Right there's 1. There's 4, 5, 6. 8, 9, 10, 11, 12. And the other ones, 2 and 3, I believe, were pulled high. Yep. And there's your output. Garbage output. So I am going to go ahead and replace the LS30 right there. And we'll see what that does. Alright. Got the LS30 in the board, and this ground pin folded up on me. So I soldered the heck out of it to ground it. It folded. Didn't go through the hole, it folded. So I soldered it good, it's in there. But now if we look at the output on that guy, you see it's a nice signal. Nice enable pulse. And better yet, our paddle is back in action. And even better yet, it is silky smooth. It's not quite silky smooth over there. It's a lot better than it was, but it's still not perfect. We'll have to figure that out. And we will. Alright, so I'm gonna check out the what we have here is a 4066 that is socketed, that is used in the paddle circuitry. So I could really easily just swap a new one in there and see if it smooths it out. So I'm gonna go ahead and do that. See if that smooths out our jagged, our little bit of a flaky movement on that thing. Alright guys, I got to poking around a little bit on here, and I came to this C2, and I poked around and I found this signal right here, looking like, just looks like crap. And I was like, what is this? So I was like, what is this chip? I can't read it. It's kind of rubbed off. So I looked it up on the schematic, and it is a 7400. That is an input leg, which is also connected to this 555. So I was like, okay, what is that signal? The signal is called not attract. And I found out that not attract is used all over this board. These are all of the chips and pins that use that not attract signal. And it looks like that. It just looks like crap. That is supposed to be a TTL signal. So I was like, okay, I got to find out where that comes from. And I did. It comes off of C6. It's a 74, and it makes attract and not attract. C6. C6. It's this guy, which I've replaced. That's that signal right there. Something is corrupting this. So I'm going to look at the schematic again. I'm going to look at this chip a little closer and find out what is going on around this guy. Because I know this chip is good. And I'm going to tell you right now, that is connected to a bunch of these guys. 9602, which is some weird chip. I don't even know. But you can get them at Jameco Electronics, and I'm going to. Well, there's about 4 of them. This guy, 1, 2, 3, 4, 5, 6, 7 pins are connected to that signal. Not including this guy. So something is corrupting that. I'm going to have to figure that one out. So let me poke around a little bit, and I will be back.